Okay, let's start 7-5, which is about fractional exponents. So I see this right here, fraction, and we know what exponents are. So fractional exponents are exponents that are fractions. And root 16 is actually like square root of 16, and the square root of 16 means 16 with an exponent, let's change colors, of 1/2. So square root has a 1/2 as an exponent. And the square root of 16, what number makes 16 when you get 2 of them? And that's 4. This is the cube root of 8. That's 8. Based on how the square root was a 1/2 exponent, can you guess what the cube root is as an exponent? It's 1/3. So what number multiplied by itself 3 times gets you 8? And that would be 2. Fourth root of 16 is 16. And that exponent, hopefully you see the pattern now, is 1/4. Again, the same question, but now it's 4. What number 4 times multiplied by itself 4 times gets you 16? And again, that answer is 2, because 2 times 2 times 2 times 2 gets you the 16. So another way, I'm going to write it right here for this example, another way to write this part, that's the fourth root, I haven't changed anything yet, is 2 to the 4th. 2 to the 4th to the 4th root, it's like they cancel out, they're inverses of each other, and that's why the answer is just whole number 2. We'll practice this again in class. Let's take a look at example 1. We're told to simplify. In example A, we have 125 to the 1/3. I'm going to write the 125 inside, and the 3 in the denominator. That's what makes it a cube root. So what number multiplied 3 times makes 125? That's the question. What number multiplied by itself 3 times makes 125? Well, 5 times 5 is 25. Times 5 is 125. So it's 5 to the 3rd cube rooted. The answer is 5. In example B, we have 2 pieces now. We have 32 to the 5th root plus 9 to the square root. And if it's just 2, usually that 2 isn't written. It's just regular square root. Oops, and this is supposed to be 32, not 35. So what number multiplied by itself 5 times makes 32? And what number multiplied by itself makes 9? Well, I'm going to start with 9 because that's the easier one to see. 3 times 3. Now I need to make 32. I'm going to start with the number 2 because that's the most common. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and that was 5 times. So 2 to the 5th with the 5th root makes 2, and 3 squared square rooted is 3, and 2 plus 3 is 5. Let's try another one, 64 to the 1/3. So what number multiplied by itself 3 times makes 64? And then the square root of 36. And I know the square root of 36 is 6. So what number multiplied by itself 3 times makes 64? It's not 3, because 3 times 3 is 9, times 3 is 27. So let's try 4. 4 times 4 is 16, times 4 is 64. And you'll get used to seeing that as well. So 4 to the 3rd with the cube root, I get 4 plus, and we already said the square root of 36 was 6, and 4 plus 6 makes 10. Now, these examples so far have all had 1 in the numerator, and we've just looked at the denominator, and that's been the root power. Now we have fractions that have a numerator not of 1. And when you see something, the first example is with variables 8 to the mn. The n still decides the root power. Okay, that's not changing. Here it's the root power, here it's the root power. N is still the root power. 8 still goes inside, and now the numerator of m means 8 to the m. And usually it'll be written that way, but it could also be written like that. You'll see it both ways, and your book has it both ways. Okay, let's take a look when the fraction doesn't have variables, but it actually has the numbers. So 8 to the 2/3. The 3 becomes the root power. The 8 goes inside. And I like writing it, we don't need the parentheses, but the 2 on the inside, like this format. I like that way a little bit better, but both ways will work. So we have the cube root of 8 squared. There's a couple different ways to see this, but what works for me, and in class we'll talk about the other ways too, 8 squared is 64. So I'm going to simplify, like order of operations, I'm going to simplify what's inside, and then I'm going to take the cube root of it in this case. So what's the cube root of 64? Well, like we just saw in this example right here, the cube root of 64 is 4. So 8 to the 2/3 power is an answer of 4. It's not even a power, it's not even an 8 at all. So that's what's really cool about these fractional exponents. Alright, so let's try a couple more and then it'll be your turn. 81 to the 5/4. So my 4 is my power, and my 81 is to the, oh my gosh, to the 5th power. Now this is a case where I wouldn't want to find 81 times 81 times 81 times 81 times 81. So I'm going to show you the other way to do it with this example 2a. If this was a 4, they would cancel out. So I'm going to split this into 2. And I'm going to have the 4th root of 81 to the 4th times the 4th root. I need one more 81. Okay, because 81 to the 4th plus like an 81 to the 1, that makes my 5. So I'm splitting it into 2. The 4th root of 81 to the 4th, right, those are inverses, they cancel out. So that's 81. And now I need to know what the 4th root of 81 is. Well, I'm going to start, it's odd, so I'm not going to start with 2, I'll start with 3. 3 times 3 gets me 9. And another 3 times 3 gets me 9. So it takes 4 3's to make 81. And I want that number multiplied by itself 4 times since I'm in the 4th root. So the 4th root of 81 is 3. And 81 times 3 is 243. And that is the answer for this one. So in this one, let's go back a second. Here, because this was a 2, it's easy to simplify. So that's why I did it this method. With this number, I wouldn't want to do 81 5 times. So that's why I did it the other method. We'll practice both tomorrow. Let's try example 2b, 32 to the 4/5. So this time, let's erase this so I have more space. My 5 is my denominator, so I'm in the 5th root of 32 to the 4th. Okay, so this time my exponent on the inside 4 is smaller than my exponent on the outside of 5, so I can't do it the same way I did a. In this example, simplifying it, 32 to the 4th, I don't really want to do that either. So I want to think of another way that I could change these numbers without actually changing the value. And here's what I'm thinking. Let's change that 32 so that it's a number to the 5th power. And then we'd get these 5's to then cancel out. So is there a number that multiplies by itself 5 times to make 32? It's even, so let's start with 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1, 2, 3, 4, 5. That's 5 2's. So 32 is just 2 to the 5th. All I did was rewrite this 32 as 2 to the 5th. I haven't actually changed the value at all. I just rewrote it. So now 2 to the 5th, so now 2 to the 5th root, those still cancel out, and now I'm left with 2. But this 4 doesn't go away. It's still there. So what's 2 to the 4th? And 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. The answer is 16. So 32 to the 4/5 is 16. Whew, this was a long one. Thanks for your patience, everyone. Here, I simplified first. This example, I'm sorry I had to erase it. I separated this into 2 pieces, and this time on example 2b, I split the actual number in the root in order to get those exponents to work out. So that's 3 different ways, depending on what number you're given. I want you to try it. So please do check it out, 1A, 1B, 2A, 2B, 2C. There's other examples in the book for you to look at as well. And the check it out start on page 423. Make sure to bring your work to class tomorrow, and we will talk about this tomorrow. Thanks, everyone. Good night.